open up our terminal. So if you go to the top here, terminal, new terminal, and in here we're going to type npm I, and that is going to install all of our dependencies. Now we can run the program by typing npm run generate. This is going to generate 5 unique images based on the layers that we have here. And if you have any issues here, be sure that you installed Node.js properly on your system. And these images are created in a folder called build. We can see our images here, and we can preview them. Let me close the terminal, and we can preview these images. Each one is unique.
I am set and go.
ABC Tuesday. Critics are raving about the hit comedy with 100% on Rotten Tomatoes.
You want to go celebrate with me?
You know I can't be seen in public with you.
A simple no would be fine.
Abbott Elementary, Tuesday on ABC and stream on Hulu.
And then notice along with the images, we also have JSON files. And these are the data files that define what options are contained in the related image. These will be used during the NFT minting process to define each attribute on each image. We can see in here we have a name, description, a link to the image, DNA, edition, date, attributes, trait type, value, and the compiler. The platform that we're going to use to upload and mint these NFTs uses what's called an ERC 721 contract. This is an industry standard way of formatting the metadata. There's a link in the description for more information on the ERC 721 specs. And because of this, we're going to slightly modify the way that our metadata is created. So let's go over here, and we're going to open up in the source directory the main.js file. Now this might look intimidating, but don't worry, I'll walk you through this. So we're going to scroll down here, and it's somewhere around 133. So we have this image here in our metadata. We're going to change image to file URL, just like that. And then we're going to move DNA, edition, date, compiler into their own object. We're going to call that custom fields. So curly braces, and then on the inside of that, let's cut this out. We'll paste it here. And also on the compiler, we'll paste that there. Then we need a comma after this object, and we can delete this line here. And then we'll need to scroll down to line 306. And here it's referencing the meta. We'll just need to add the custom field here. So meta.customfields.edition. So that is all we're going to do in this file. Let's save this, and we can close it. Next, we're going to change out these example layers with our own layers. So to do this easily, we're going to go inside of our File Explorer. So I'm going to right-click, Reveal in File Explorer. And now we can see all of these existing layers. We're just going to delete everything there. And then I'm going to paste in all of my layers that I exported from Figma. You can see I have a bunch of layers here. Accent color, background, ear, eyes, eyewear, fur, head, laptop, and a bunch of logos, mouth, neck, nose, ton of layers. We can close this and go back in VS Code, and we should see our new folders and files here. Now each one of these is a folder, and then within the folder we have our options. Right, so next let's go to source and then config.js. In here, we're going to update the name prefix and description with our own. So let's go down here, name prefix. So your collection, you'll want to change this to whatever you're going to name your collection. Mine is code cats. And then a description. So add description here. Now the base URI, we're going to update later because we don't know it quite yet. We're not going to worry about this Solana metadata because we're not using Solana. So now scroll down here under layer configurations. First, how many images or additions do we want to create? So we're going to change the grow size from 5 to 10,000. Now initially we're going to want to just test this to make sure it's working. And once we get 5 good images out of it, then we'll change it to 1,000, 10,000, however many you want to create. And I'm going to go ahead and change mine to 10,000. Now under layer order, we're going to change these out for our layer folders that we just copied over. And be sure to order these correctly. The first layer needs to be the furthest background layer, and the last layer needs to be the closest foreground layer. Also, the names of the folders are important. These are going to be used in the metadata as the attributes. So let's open up my folder structure here. So under layers, we're going to add all of these into layers. So background, that is the background, that's what I needed. I'm going to speed this up for time because there's a bunch of layers for me to type in here. Alright, so I finished adding all of my layers. There's a ton of them. And then I want to show you one other thing. So under my layers, and then in certain ones of these, like eyewear, I've got sunglasses, cool glasses, glasses, hard glasses, but then I have a blank. This blank is just a blank transparent image. This was the easiest way for me to have some images not have eyewear, they'll just be blank. So I added that into all of my logos as well, so not every logo is going to show up, just certain ones. And then like on the hats, we have a blank in there as well, so the cat won't always have a hat. And so I hope that makes sense. Now we'll scroll down in the config.js file, past all of that. I'm going to change my format to 1500 by 1500, but you can add whatever you want here. This is just my preference. Then scroll down a little bit further. Under extra metadata, we're going to enter a field here. And again, this is just personal preference. I'm going to add an external URL, and that is going to be the website of my collection. And this is going to show up on OpenSea for each NFT. And we're also going to define a rarity for each layer option. And to do this, we'll edit each layer option file name. And you might have noticed my file names might look a little strange. If we go under background, you'll see that I have at the end of the file hash 100, hash 100, hash 1, hash 100. So this is a weight that we can give each option. If we want something to be very rare, then we could say hash 1. And then for something very common, hash 100. And these are just arbitrary numbers. It could be 1,000. It could be anything that you want. It's just a weighted number. If we made all of them 1, then they would all be equally used. In this instance, purple is going to be very rare. So I went through and added that to certain options. So under pupils, we have a normal pupil is 100, and then frost and paranoid and rolling eyes, these are more rare. And you want to play around with these numbers to get a good mix. So I did the same thing under logos. I have a blank, which is going to show up 10 times more than the logo itself. If you just want everything to be equal, you don't have to add a hash at all. You can just leave it, and they'll all be equally weighted. Now there are a ton of other advanced configurations that you can do with this engine, like create GIFs, use blending modes, pixelate images, and much more. If you have more advanced needs, go check out the Hashlip's YouTube channel, where he goes into much more detail, and there's a link in the description as well. Now this is all that I need to change. Alright, so now let's run this and get 10,000 unique images. Let's open up our terminal. Remember, we can go to terminal, new terminal, or just press Control backtick. That's the key next to the 1. Let's type npm run generate. Now, depending on your system, this could take a while to generate. For me, it took just a little bit over an hour. And again, these images get saved in a folder called build. And this folder structure that you see here is the same folder structure that's in your computer's file explorer. I'll give you a sneak peek at a few of these. Right, and then if we go over into one of our JSON files, you're going to notice here that in our attributes, close the sidebar, in our attributes we have background, ear color, fur color. We want all of these. If you scroll down a bit, you're going to see blank. So if the neck doesn't have a necklace or whatever it might be, then it's going to say blank. And then it gets even more apparent when you go down to the logos. There are a ton of blank logos. So we don't want to upload these blank attributes to OpenSea. So we'll need to go ahead and modify that as well. Okay, so let's just go over to under source, main.js, and then line 170, let's close the sidebar here. All right, 174, we're going to add a new line here. We're going to say if selected element name, we're going to trim it. So just in case it has any white space before or after it, we want to trim that off. So we'll say trim. Then we're also going to say we're going to want this to go to lowercase. So this is going to give us the name without any white space before or after it, and lowercase to make it easier for us to match. We're going to say if it does not equal this. So to do does not equal is exclamation equal equal. So if it does not equal blank, and we're going to put blank in lowercase so that it matches. So if any of our selected items does not equal blank, then we're going to run this code after it. So after this, we need a curly brace, and then below this part here, another closing curly brace. And so if it does not equal blank, then we're going to push the attribute. If it does equal blank, then it will not get added to the JSON metadata. So now we have our images and we're ready to create our NFTs. This is where most tutorials stop and most people get confused and give up. You see, usually you're going to need to know programming technologies like Solidity, Web3.js, IPFS, and others to create an NFT collection. You have to first deploy a contract, upload your files and metadata, and then mint your NFT. And this process could take weeks to learn, but there's an easier way. We're going to use a great platform called NFTport, which is the sponsor of this video. With NFTport, we can do this entire process in minutes rather than days. On top of that, it's completely free. Just go to nftport.xyz. They have a generous free plan that includes up to 1,000 NFTs, 5 contracts, access to NFT data, and enhanced APIs. You can also apply to the community program to get bumped up to 50,000 NFTs, 15 contracts, 2 times higher rate limits for NFT data, 50 megabytes IPFS file upload limits, and more. To get started, all you have to do is get your free API key. It'll be emailed to you right away. The documentation for NFTport is great. We can easily mint a single NFT with just a single terminal command. But because we want to create our own collection, we'll need to first create a contract. And to do anything on the blockchain, we're going to need a wallet. And I recommend the MetaMask wallet. If you don't already have it, just install it as a browser extension and sign up. Go to metamask.io to download it. Again, everything in this video is completely free. This is just going to allow us to assign ownership of our collection and NFTs to our personal wallet address. This is just how things are tracked on the blockchain. Alright, so now back on NFTport, let's go to the documentation. Now if we scroll down, under minting contracts and storage, you'll see contracts here, and deploy an NFT contract. A contract is required in order to mint NFTs. NFTport uses the ERC 721 standard that we talked about earlier for its smart contracts. A smart contract is like a manager for your NFTs. The contract keeps track of them all. It can verify ownership, handle transfers, allow you to update existing NFTs, and much more. So the first step to creating an NFT collection, or even just a single NFT, is to create a contract. And we can actually create our contract right here from the documentation. You'll just need to add your API key here under authorization, and then update the name of your collection. I'm going to call mine Code Cats, and then you'll want to enter your owner address, which you can get from MetaMask. So just go up to your extensions and open up MetaMask, and then right here you have your account number. Just click that to copy it and paste it here. For the symbol, we'll leave that at C. And for the chain, I'm going to recommend initially to use the Rinkeby chain, which is a test chain. It allows you to play around and test before deploying it to the actual Polygon chain. So I'm going to change this from Polygon to Rinkeby. And in the documentation, again, it's very good. We scroll down here, you'll see all of the options. So for chain, allowed values are Polygon or Rinkeby. the name, symbol, owner address, and then we have this meta updatable. I'm going to actually add this to my contract, and I'm going to set this to true. Some advanced planning is needed. My plan is to mint all of the NFTs, but reveal them only after purchase. So initially, all of the NFTs will have a generic image indicating that they will be revealed. After purchase, I'm going to update the NFT's metadata to point to the actual image and its attributes. If metadata updatable was not set to true, I wouldn't be able to do this. The metadata pointing to the image will already be frozen and not editable. That's why I'm adding this option. So we'll add that in the code here. We need to surround this with quotation marks, metadata updatable, true. Now we can send our request, and we get a response, 200 OK. That means that it worked. So this is on the Rinkeby chain, and we have our transaction hash, transaction external URL, owner address, the name, the symbol, all of that got returned to us. So you could go to this URL and check the status of it, but we're going to need this information, especially this transaction hash, in a little bit. So let's go ahead and click this little button here to copy all of this code and just save it somewhere on your computer. So next we're going to upload 10,000 files to IPFS. IPFS is an industry standard for decentralized storage. You could just use Google Drive or any other online file storage, and that would work. But that is centralized storage and defeats the purpose of decentralization. Fortunately, NFT Port has all this worked out for us. It's really easy to upload these files. So back in the documentation, let's go to storage and then upload file to IPFS. Now here we could pick a file and send the request and upload each file one by one, but that would take forever. So let me show you an easier way. The code that we used to generate our images is called JavaScript, and it uses Node.js to run. Now, as you can see here in this code snippet, there are many different language options that NFT Port has provided. So we're going to select Node and then Fetch. And this is going to give us some starter code to work with. So let's copy this code. All right, back in VS Code, we're going to create a folder structure for some new files. So let's go to our File Explorer, and then under Utils, we're going to create a new folder. We're going to call it NFT Port. And then inside this, we're going to create a file. Let's call it upload files.js. Now let's paste that code that we copied into here. Now we're going to need to install a couple of packages to help us out. So let's open up our terminal. Remember, control backtick. Let's type npm I, which is going to install node fetch, node-fetch, and then form-data. Should just take a few seconds, and we have those installed. See, we are using form data and we're using node fetch. So we needed those to be installed for this application to work. Next, we're going to copy a few lines from the main.js file. So let's open that up. We'll go to source and then main.js. We'll need this base path and fs. Just copy that. Now let's paste it here, and we can just get rid of this network line. Delete that one. All right, base path, fs. The first thing that we'll need to do is get our images and loop through them one at a time. We're going to create a file stream and add each file into our form data. This is where we're going to get our form data. So let's move that up here. So form data equals new form data. And then we need to read that file. So we'll say const file stream is going to equal fs.createReadStream. And then it's going to be the same base path and then build images and then our file. And then after that, we can append to our form data. So we're going to append file, and then this is going to take our file stream. So what this is doing is it's looping through our images, taking each file, and then it's reading each file, and then adding it to our form data, which we're going to then submit to IPFS. So now we can use the rest of this down here. We have our URL and our options and our fetch. So let's just move that right up here. Let me close the sidebar so we have more room. So we have our URL, which is our API link for NFT Port. In our options, we're going to be posting, and for the headers, we really don't need the content types here. So let's delete that. We just need our authorization. I don't think that I said this before, but your API key is super secret. Don't let anyone else use your API. That's why mine is blurred out here. Instead of appending our form data here, we're going to move that here into our options. So we can just say body and then form data, just like that. And then we can get rid of this line here. That just makes it look a little cleaner. Now in our fetch, we're going to receive our response here in the second dot then. So this JSON is going to be the response to our request. Right now we're just console logging the JSON. In this response, we're going to receive back the link to our uploaded file on IPFS. So we need to update the image's corresponding metadata file with this newly created IPFS link, right? And so if we go over here, right, so remember each build, each image has a corresponding JSON file, and it contains a file URL, which right now is just a generic URL that doesn't actually exist. So we need to update this after we upload our file with the new link. So if we go back into the documentation, we can scroll down and see what we should expect to receive back. So here's our response. So in our response, we're going to get an IPFS URL, file name, content type, file size, and if we have an error. So IPFS URL is the item that we want to add into our metadata.
It's that jiffing good. Ludacris changed his flow for it.
So how are we going to know which JSON file to update? The JSON files are numbered the same as the images. So we're going to get back the file name in our response. We can use that and add .json. That way we'll know which one corresponds to which image. So here, instead of console logging the JSON, let's add curly braces, and then we can add some more code in here. So first, we're going to say const file name. That's going to equal path.parse. Then we can pass in here JSON.file name. And then we need the name. Right. Now we will need to bring in path as well. So let's go back up here, and let's also say const path equals require, and then path is a core Node.js package, so no need to install it. So back down here, we're getting our file name, and then we're going to get our raw data. So we'll say let raw data equal, we'll say fs.read file sync. Then we're going to use our base path again. So $ curly braces, base path, and that's in build. This time we're going to look in the JSON folder. We're going to look for the file name, and then add on to that .json. Right? So it's returning to us the file name without the .png, and then we're reading that file. We're getting the raw data. So now we need to parse it. So we'll say let metadata equal JSON.parse, and we're going to parse that raw data. Now we have a JSON object here in our metadata. So now within this metadata, we can say metadata.file URL. It's currently the wrong URL, it's just a fake URL. We need to update it with the right one. So we're going to say that equals JSON.ipfs URL. Alright, so we're updating the metadata basically in memory right now, and now we need to write it back to the file. So we're going to say fs.write file sync, and then in here again start with our base path, and then build JSON, and then again our file name .json. So that is the directory we're going to write to, and now we need to tell it what to write. So we're going to say JSON.stringify. So we need to turn this object now into a string of text that we can write to a file. We're going to stringify our metadata, and then we're going to pass it some options. We're going to say null and 2. This is going to write this string of data. Instead of one long string, it's going to write it in a readable way. All right, and then after that, let's console log. And we're going to say JSON.file file name, uploaded, and file name .json updated. Then after that we have a catch, which if we have any errors, it's just going to console error the error. So this should work. This should loop through all of our files, upload them, and then update the corresponding metadata. So let's save that. Now to run it, open up our terminal, and let's type node. So we're going to use node to run this, node, and then it's in the utils directory. So utils /nft port /upload files.js. That's the file we have open right now. So we're going to use node to run this file, and it's going to loop through, upload all of them, and update the metadata. So I only have 5 in my working directory right now, just so that I can demonstrate this. Alright, they've all been uploaded. Let's go over and check out our JSON should be updated as well. Alright, so now we have in this codecast number 1, there is a URL here. So let's open this up. And there it is. It is on IPFS. Alright, so now we have our images uploaded to IPFS, and we've updated the associated JSON meta files. So now we need to also upload these JSON files to IPFS. So we're going to start with the same code that we have here in our upload files. Let's just copy that. And let's create a new file here under NFT port, and we're going to call it upload metas.js. Alright, let's paste in that code to give us something to start with. So we're going to loop through just like we did our images, but this time we're going to loop through our JSON files. And then in our URL here for our API, we're going to change it from files to metadata. And we're not going to be adding these files to a form data, so we don't need any of that. So let's delete the form data, require, and this form data, and this as well. Now when we upload these files, we're also going to receive some data back that will have the metadata URI that we need in order to mint our NFTs. So we're going to need to save all of this data to another file, which we can reference later. So we're going to start out by writing a file called _IPFS metas.json. And we're going to make it empty. And if the file doesn't exist, then it's going to be created. If it does exist, it's going to be cleared. So it's going to be in our base path, build JSON IPFS metas.json. And then initially the value is going to be blank. And then we're going to create our write stream. So create write stream. This is going to allow us to open a file and write to it over several operations and then close it, instead of opening it, writing, closing it over and over 10,000 times. We're going to add the flag A to the write stream, which allows us to append. We need to add this to a variable, so we'll say const writer equals. Alright, so now we can call writer every time we want to add something into the file. So initially, we're going to say writer.write. Since we're writing several objects into our file, we're going to make this array by starting it with a square bracket. Then we're going to create a variable called read directory, reader, and that's going to equal our base path build JSON. And then we need to keep track of our total file count. So we'll say let file count equal fs reader sync, pass in our read directory, and then get the link. From this, we're going to subtract 2. There are 2 files that we want to skip, the metadata.json and the IPFS metas.json. Next, we're going to look at our for each here, where we're looping through each file. We also don't need this file stream. So first, we're going to say if file equals _ metadata.json, and then the two pipe characters means or. So or file equals, this is triple equals, equal 3 times. So if it triple equals underscore IPFS metas dot JSON, then we're just going to return. So when looping through these files, if we come across one of these two files that we want to skip, we're just going to return, which will just move us on to the next file. The code after the return will not be executed. So let's read the file next. So we'll say const JSON file, and that's going to equal fs read file thing. And then we'll pass in here our read directory and then our file. Alright, so now we have our file and we can pass it into our options. So in the headers, I'm also going to add a content type application JSON so that the server knows that we're passing it a JSON file. And then instead of form data, we're going to use JSON file. So in the body, we're passing the JSON file. This time when we receive our response, we're going to write the data to our write stream and then deduct 1 from our file counter. So let's delete all of this from the previous version, and we're going to say writer.write JSON.stringify the JSON that we receive back and print it so that we can read it. And then we're going to deduct 1 from our file count. So file count, and if we just do a minus minus, that will deduct 1 from the file count. So now we're going to check to see if we're at the end of our files. So we're going to say if file count triple equals 0, it means we're done looping through. And we'll say writer.write, and we need to add our closing square bracket. And then after that, we can say writer.end, and that will close our file. If we're not finished, we'll say else writer.write, and we're just going to write a comma and then a new line character. That's \n. It's like a carriage return and adds a new line to the document. Alright, so then let's console log. We're going to say console log JSON.name, and then metadata uploaded and added to IPFS metas.json. Alright, we can save that. Now remember that I said that I'm going to reveal my NFTs after purchase. This means that initially they're all going to have a generic image and no attributes. So that way you have no idea what you're going to get until you purchase it. You could get a common NFT or maybe a super rare one. It's like buying a pack of trading cards. So I'm going to create a second set of JSON files from my NFTs. In these, I'll redact the DNA and attributes from the JSON files and then update the file URL to a generic image that all of the NFTs will have initially. Now you don't have to do this. You can skip this step and just upload these as is if you wanted to. So if you don't want to go through this reveal process, you can skip to the next timestamp. Alright, so I'm going to create another file. Come over here, NFT port, new file, and I'm going to call it generic metas.js. We're going to use a lot of the same code as we did before. So over here, let's just copy this and paste it in here. This time, let's get our build directory as well. So we'll say const build directory is going to equal path.join our base path, and then we're going to add on to that /build. First, we're going to create a new folder called generic JSON if it doesn't already exist. Then we'll get rid of the write file sync that we don't need anymore. Then we're going to loop over the JSON files, skipping the 2 extra files like we did before. Then we'll read the current JSON file. We'll change the name, description, update the file URL, and delete the attributes and DNA items. Then we can delete the entire fetch request that we don't need. Lastly, we're going to write the new file into the new directory. And then we'll console log the file was copied and updated. And for the file URL, I'm just using a generic image that I uploaded to IPFS. You can use the NFT port docs to upload a single image easily under storage, upload a file to IPFS, which we looked at earlier. Now to run this, we can open up our terminal, and if you hit the up arrow, it's going to bring you your last command. But we need something very similar. This time it's going to be /NFT port /generic metas.js. To run that, and it has copied 5 of them. So if we go up here to build generic JSON, we should now see some generic JSON. So now we only have the name, which is now unknown, description unknown, this generic image, and then our custom fields no longer has DNA. We still have our external URL, we still want that, and the addition, everything else is fine. So now back in the upload metas, now I'm ready to upload my metas because I wanted generic ones. You may have wanted to upload the real metas, and that's fine. So now we're going to run this. If we go up here to our read directory, this was important from before. Everything below line 11 is referencing our read directory. Actually, I just noticed one thing that's not. We need this to say read directory. So since everything is referencing this one variable, we can easily change this to whichever directory we want. Right, so JSON is our real metadata JSON files, but I want to change this to generic JSON and upload these files. And because we're reading from the generic JSON, this time we don't have these 2 files to account for, so we don't want to subtract 2 from our length, otherwise we'll be short 2 responses. So if you're using the regular JSON, make sure you subtract 2. So I'm going to save that. And then to run this, we'll open up our terminal, and we'll hit up arrow to get our last command, and we'll change this to /upload metas.js. So now we ran that. They've been uploaded and also written to our _IPFS metas JSON. So if we go over here and we go into our JSON directory, we should now see IPFS metas.json, and we can see what was returned from uploading these. We have our metadata URI for each one of our NFTs. This is what we're going to need whenever we mint them, which we're about to do. Right now that we have our files uploaded, we can actually mint our NFTs. There are 2 items that we need, the contract address and metadata URI. We can get our contract address using the transaction hash that we got from deploying our contract. Remember I told you to copy that and save it earlier? If you forgot, it's not a problem. We can use another great feature of NFT port. Here under user, we can go to list all your deployed contracts. And then just put your API key in here, send the request. And there's a few tests that I had in here, but at the bottom, we should see code cats. And the address here, that is the contract address. Alternatively, we could have gone under contracts, retrieve a deployed contract, and then under transaction hash, paste that hash that you got back, and then change this to either Polygon or Rinkeby, whichever chain you deployed it to. Send the request, and again, we're going to get our contract address here. So let's copy that. Remember, things on the blockchain are permanent. There are lots of ways to track things down. Let's go back into VS Code, and we're going to create another file. So let's go to our files here under NFT port, and we'll create one called mint.js. And let's copy from the upload metas. A lot of it will be the same, but we can close that and paste that here. So we have our contract address. The other thing we needed was our metadata URI. And all of those are in our IPFS metas JSON file that we saved after we uploaded our metadata. Right, so we're going to first get that file. So we'll say const IPFS metas is going to equal JSON parse, and it's going to be fs.read file sync, and then we'll use our base path that's in build JSON, and then underscore IPFS metas.json. We're going to create a new file to save our response data for each NFT. Now this is not totally necessary because they're just going to show up in your wallet, but I like to keep track of things. So this time we'll create a file in the build directory called minted.json. And this time, instead of looping through files, we're going to be reading one file, the underscore IPFS metas.json file, and then loop through its content. So we'll keep track of the count again too. We'll update the URL and create a mint info object. This will contain the chain, contract address, metadata URI, token ID, and address that we're going to be minting each NFT to, which should be your address from MetaMask. For the token ID, we'll just use the edition number. And for the metadata URI, we're going to get that from our meta object in the IPFS metas JSON file that we're looping through. Each time, we're going to get a new URI to mint. When we get our response, we'll write the response to our write stream, deduct from our counter, and then close out our file like we did in the update metas file. And lastly, we'll console log the transaction external URL of the minted NFT. So let's save it, open up the terminal, and we can run it. Press the up arrow to get your recent command, and then we can just backspace that and then run mint.js. And there we go. We have 5 that have minted here. We can check the progress of each one on Etherscan, and it should take a few seconds. So we can click on one of these and open them up. And you can see it's still running. Alright, so that succeeded. We can also check on OpenSea for the item. It's probably going to take a few more minutes to show up on OpenSea. And since I used Rinkeby, I'm going to go to testnets.opensea.io. And if you deployed them to the Polygon chain, then you should just go to the normal OpenSea.io. Now, the first time that you go to OpenSea, you'll be prompted to sign in using MetaMask. After that, just go to your profile and you should see them show up. Now, if some of them don't have images or metadata, just give it a few minutes. And if they still don't show up, then you may have missed a step. You can use the lookup features on NFT Port to verify the items that you've minted, and then try to track down the issue using the data files that we saved. Also, whenever you go to one, you can see that mine still haven't showed up yet. If I go in here, there's a refresh meta button. So after some time, if it still doesn't show up, click the refresh, give it a few more minutes, and then check back. In the near future, I'm going to update the site for this collection to add purchase functionality. You'll be able to purchase an NFT, and the site will update the NFT's metadata to the actual data. So go check out the site and sign up for updates. It could already be functional by the time you watch this video. And I'll have another entire video on how to integrate all of that into your site. But for now, I'll show you how to use the NFT port docs to update an NFT. Right now, if you just wanted to mint 10,000 NFTs and you're not going to do a reveal, then you're done. You can skip to the next timestamp. We'll need 3 things: the contract address, token ID, and the new metadata URI. Now note that the contract must have been created with the metadata underscore updatable field set to true for the associated NFTs to be editable. And we only have 2 options that we can update. We can update the metadata URI, which will update the NFT's image URL, attributes, etc. And we can update the freeze status. If we pass freeze underscore metadata equals true, this will freeze the NFT and will no longer be updatable. And that is what we would want in our situation after the purchase of the NFT. So first we need to upload the actual metadata for the NFT to IPFS. Now remember, before we uploaded generic data with generic images. Let's use the NFT port docs. So we can just go over here to upload metadata to IPFS. You could use the code that we wrote earlier to upload a bunch of them, but I'm just going to show you one example of updating one NFT. So back in VS Code, I'm going to look at one of the actual JSON files here, and I'm going to copy the contents here. We have name, description, file URL, custom field. I'm going to copy all of the contents of this. And then back in here, I'm going to delete what was here before and paste over it. It doesn't matter that it looks like garbage there, but as long as we have our API key and we have all of this here, we should be able to send the request. And we get a 200 OK, that's good. And now what we need is the metadata URI. So let's copy this. All right, so now let's go over here under minting, update a minted NFT. So in here, let's change Polygon to Rinkeby. If you uploaded yours to Polygon, that's fine. Leave it at Polygon. The metadata URI in my clipboard, so let me just go ahead and paste that first. The token ID that we're going to update is 1. Now you can get your token ID back under OpenSea. You go down and you find it was this one. And I know it's number 1 because that's number 1. And then under details, we have a token ID of 1. I know this is the one that I wanted to update. So back here, we have our token ID, our metadata URI. We need the contract address. Now I had that over here in the, let's see, mint should be in here. Here is the contract address. Copy that and paste that here. Alright, so Rinkeby contract token. It's going to update the NFT with a token of 1 to this new metadata URI. Right, so let's send that. And we got a 200. Good. Now one thing that I forgot to add on to here was freeze metadata and set that to true. Those are the quotation marks there. So if I would have added this, it would have froze the NFT so that I can't update it again. So right now in our response we have freeze metadata is false. So let me go ahead and just send this one more time. And now it is frozen. I can't change it ever again. Again, we can go back to OpenSea and refresh. And we'll need to wait, refresh, update the metadata, wait some more, refresh again. Eventually the changes will appear. Now this has nothing to do with NFT port, it's just the way that blockchain works. It takes time for everything to update. Alright, so I actually had to wait about 4 hours for these to finally update on OpenSea. And again, this has nothing to do with NFT port, this is just the way things work on the blockchain. It takes a while for things to propagate and update. Alright, so this is what one of my NFTs looks like before it's revealed. It's just a cat carrier and you're not sure what's going to be in there. If we go down, we can see that there are no properties. There's just the normal details. And then if we scroll back up here, there is a link to go to the website. So this is what it looks like after it's revealed. We have the actual NFT. We still have our link up here that goes to our website. And then in the sidebar here, we also have properties. And so here are all of our properties for this particular NFT. Okay, so we went through all of that in order to test out our NFT uploading and minting scripts. Now it's time to upload the actual 10,000 NFTs to the Polygon chain. This time I have all 10,000 images and JSON files in my build directory. I've created a new Polygon contract, the same as we did with the Rinkeby contract. And I've changed the chain in our code to Polygon instead of Rinkeby. This is a time lapse of the images being uploaded to IPFS, the metadata being uploaded to IPFS, and then the actual minting of the 10,000 NFTs. The entire process took about 12 hours total. It just takes time to upload and mint that many NFTs. Here's the final collection on OpenSea. Again, these are generic images of cats in carriers. When they get purchased, I'll update the metadata to point to the real NFT, which will be random. Now I'll be creating a video on how to automate the metadata update on purchase. So be sure to subscribe so you don't miss it. I'm going to be giving away a bunch of these NFTs. I'll be doing routine drops letting you purchase random NFTs as well. So join my Discord for more information. If you want to check out this NFT collection that I created, go to codecats.xyz. There's a link in the description as well. Now, NFT port is a great gateway or bridge from Web 2 to Web 3, and it's not only limited to minting NFTs. They have other features as well that can be used in all kinds of apps, such as searching for multi-chain data, recommendations AI, and a duplication detection AI to protect your assets. So don't be afraid of the complexities of Web 3. Dive right in and learn about the space and build NFTs and NFT apps with NFT port, and in general, just join the Web 3 revolution. It's exciting, interesting, and brings so many opportunities. If this video was helpful, give it a like and subscribe for more content like this.
Hey everybody, this is Gregory from DAP University. So today I'm going to show you how to write your first blockchain application. I'll show you how to create a to-do list that's powered by Ethereum smart contracts. I'll show you how to create your first Ethereum smart contract with a Solidity programming language, or write tests against the smart contract, deploy it to a blockchain, and we'll also create a client-side application for the to-do list. So if you're new around here, be sure to subscribe to this channel and click the like button down below. And also, you can download my courses for free on my website over at dapuniversity.com/free downloads. I've got a link to that down in the description below. And also on my website, you can find a full-length article to accompany this video. You can actually follow that step by step as you're following this tutorial. And I've also got a link to that in the video description. So before we start actually building the application, let's get a high-level overview of how a blockchain application powered by smart contracts actually works. So how does a blockchain work? And how does a blockchain application work? Well, I've chosen a to-do list for this tutorial because that's a really common way to learn any new technology, and I want to use that to show you how a blockchain application works. So first, let's look at how a to-do list would work as a web application, and then I'll show you how it would work as a blockchain application. So I'll pull my whiteboard up here to demonstrate. So normally whenever you access a web application, like a to-do list for example, you use a web browser and you connect to a web server over the internet. And you access, all the code and all the data from this web server. So like this, you basically connect from your web browser to the server. And on the server, it contains all the client-side files like HTML, CSS, and JavaScript. It contains all of the back-end code for the server, right? And the business logic you might write. And any data that's stored in your application is stored in a database, right? And pretty much any other to-do list tutorial that's out there is going to show you how to write, a client-side application in HTML, CSS, and JavaScript. And then it's going to show you how to basically do some business logic on a web backend that creates, reads, writes, updates, to-dos, and then puts them inside of a database like this, right? And all that's on a central server. And that's how you build a to-do list on a web application. So how would you build a to-do list on a blockchain? Well, it would work a little bit differently. So instead of connecting directly to a server, we're going to access our to-do list via a browser, and we're going to connect to a client-side application that we will build. And this will just be a simple client-side application on a web server. But this client-side application isn't going to talk to a web backend and a database. Instead, it's going to actually talk directly to the blockchain. And on the blockchain, we're going to have code that's going to be written with Ethereum smart contracts that will contain all of the business logic for our to-do list. And all the to-do items are going to be stored on the blockchain itself. And that's fundamentally how a blockchain application works, and how it's different from a traditional web application. So that might bring up a lot of questions, like, well, how do we connect to a blockchain, and how does the blockchain work? Like, what even is a blockchain? Well, I'll pause here and tell you a little bit more about that. So what even is a blockchain, right? Our client-side application is actually talking to a blockchain right here. So it's actually a separate network, okay? And a blockchain is a peer-to-peer network of nodes that all talk to one another. It's a distributed network. So there's actually different computers or machines that talk to one another. And we can connect to an individual node on the blockchain in order to use it. That's what our web application is doing here. So all of the nodes on the network participate in running the network. They all contain a copy of the code on the blockchain and all of the data on the blockchain. And all of the data on the blockchain is contained in bundles of records called blocks, which are chained together to make up the blockchain. And all the nodes on the network also participate in ensuring that the data on the blockchain, the public ledger, is secure and unchangeable. And that's what makes the blockchain so powerful. And so what about the code on the blockchain? Well, all the code on the blockchain is contained in smart contracts. So smart contracts are basically just programs that run on the blockchain. And they're going to be the building blocks of blockchain applications. And that's what we're going to build our to-do list out of. We're going to write a smart contract that will contain all of the tasks in the to-do list and allow us to add new ones and complete them and things like that. So smart contracts are written in a programming language called Solidity. And all the code in the smart contract is immutable, which that means it's unchangeable. Whenever we deploy it to the blockchain, we won't be able to update that code. And that's important to understand because that's what makes the blockchain so secure. Whenever we put code on the blockchain, we know we can trust it at that point. It's called trustless for a reason. Whenever it's on the blockchain, we know that no one will change it, and therefore we know the to-do list will behave the same way every time. And sometimes I actually think about smart contracts kind of like microservices on the web. They're on the blockchain and they read and write data from the blockchain and they do stuff with it. They execute business logic. All right, now I'll go back to the drawing board and kind of give you a refresher about how our application is going to work. Again, we're going to connect to the application with a web browser, and we're going to build a client-side application in HTML, CSS, and JavaScript. And that client-side application is going to talk directly to the blockchain. And that's where we're going to put our smart contract. We'll create the to-do list with an Ethereum smart contract written in Solidity, and we'll compile it and deploy it to the blockchain. And we'll also connect to the blockchain network with our personal account with an Ethereum wallet in our browser. I'll show you how to get that set up in this tutorial as well. So now we've seen how blockchain works and how we can build our to-do list application on the blockchain. So let's jump in and start programming. Here's a preview of the application that we'll develop in this tutorial. This will be a to-do list powered by an Ethereum smart contract, where we'll be able to add new to-do items, and we'll be able to check items off of the to-do list. And before you get started, you need to make sure you have Node.js already installed on your computer. You can see if you have Node installed by going into your terminal and typing node-v. You can install Node with a package manager like Homebrew, or you can download it directly from the Node.js website. The first item in the Blockchain Developer Toolkit is a personal blockchain. We're going to use Ganache as our personal blockchain for this tutorial. You can head over to truffleframework.com/Ganache to download it. You can click this download link. And whenever you've downloaded it, make sure you install it. And when you open it, you've got a local blockchain running. So what is Ganache? What is a personal blockchain? Well, a personal blockchain is like a real blockchain network, that's connected to the public, or anyone can connect to it, but it runs on a computer. It's, a closed network. And Ganache basically, is a process that runs on a computer that spins up this blockchain and runs on a server. So we can use this to develop smart contracts, we can run tests against it, we can run scripts against the network, develop applications that actually talk to this blockchain. It's really helpful, and it's an invaluable tool in the Blockchain Developer Toolkit. So if you open Ganache, you'll see 10 accounts listed here. These are the addresses to each account on the side, and you'll see these balances. You'll see 100 Ether. This is the Ethereum cryptocurrency that each account has, and is required to pay gas fees in the network and stuff like that. All right, so that's an overview of the Ganache personal blockchain network, and we're going to leave Ganache here set up in our project because we're going to need it running in order to develop our project. The next dependency is the Truffle framework. We're going to use the Truffle framework to develop Ethereum smart contracts with the Solidity programming language. You can install Truffle by going to your terminal and typing npm install -g truffle at 5.0.2. And it's important that you use this exact version in order to follow along with this tutorial. So Truffle is a suite of tools that allows us to develop smart contracts, write tests against smart contracts, deploy smart contracts to the blockchain. It gives us development console, and it also allows us to develop client-side applications inside of our project. So it does a lot, and I'm going to show off all those features in this tutorial. The next dependency is the MetaMask extension for Google Chrome. Remember, the Ethereum blockchain is a network, and we need a special browser extension in order to connect to that network. And that's where MetaMask comes into play. MetaMask will allow us to connect to the blockchain with our personal account and actually interact with the smart contract that we'll develop in this tutorial. You can install MetaMask by going to the Google Chrome Web Store and searching for MetaMask and clicking install. And once you've installed it, just make sure that you enable it inside of your Chrome extension like this. You can also see the little fox icon in your extensions tab. Now let's create the project. I'll start by creating a directory for our project like this. ETH just stands for Ethereum, so I'll enter into that newly created directory. And now once we're inside of here, we'll actually create a new Truffle project. But before we do that, I just want to make sure that you're using the correct Truffle version. You can check your Truffle version like this, Truffle version. And you want to ensure that your version is the same as mine, which is 5.0.2. So if it's not, go ahead and check out the dependencies section of this video to see how to install this specific version of Truffle. So now we'll initialize a new Truffle project like this. We'll just say Truffle init. All right, and now we've successfully unboxed a new Truffle project. And now I'm going to actually create a package.json file in order to pull in some development dependencies for the project. We'll say touch package.json. All right. And now I'm going to open this project inside of Sublime Text. That's the text editor I'm using. So let's go to the package.json file. We can actually see the project directory over here. And you can see the newly created package.json file. And it's empty. I'm going to paste in the contents of this file that we'll use for this tutorial. And you can actually get this package.json file by cloning this repository on the GitHub link in the description down below. All right, so here's the dependencies for the project. I'm just going to go ahead and save this. Like I said, I just pasted these in here. And you can see we have a few dependencies like the Bootstrap framework. We'll use this for building out the client-side application. We've got some dependencies for testing the smart contracts, a server for running the client-side application, and some other Truffle-specific development dependencies. And I've locked these versions so that you can keep following this tutorial in the future. So make sure that all these versions match what I have here. So now I'm actually going to install the dependencies for the project like this. So just say npm install. All right, so now they're installed. Now let's go back into our project and actually create the smart contract file that we'll use to build the to-do list. We'll do that by going to the contracts directory, and you can see there's a smart contract that exists inside of here. This is actually a smart contract that comes bundled with Truffle that manages migrations to the network, and I'll explain that here in a little bit. And now I'll create a new file inside this directory called to-do-list.sol. So we can see that to-do list is capitalized, to-do list, and it's in the same project directory here. So now let's actually create the smart contract that will manage the to-do list for the application. The first thing we want to do inside this file is actually declare the version of the Solidity programming language that we want to use. We'll do that like this. We'll say pragma Solidity. We'll use a caret. We'll say version 0.5.0, and we'll end this line with a semicolon. All right. Now the next thing we do is actually declare the smart contract. We do that with the contract keyword. Say contract. And we want to call this contract to-do list, which is the same name as the file. So to-do list. And we follow that with some opening and closing curly braces. And inside of here is where we actually write all of the code for the smart contract. Now I'll go ahead and bump the font up so that you all can see this a little better. So the first thing that we'll do inside of here is just keep track of the number of tasks that are in the to-do list. And we'll store this value inside the smart contract as a way to kind of get started and just make sure that everything is set up properly in our project. We'll deploy this simple smart contract to the blockchain and actually see if we can connect to it before we do anything any more complicated than that. So first, we'll keep track of the number of to-do lists inside of the smart contract with a variable. And it'll be a special kind of variable in Solidity called a state variable. And we can declare a state variable like this. We'll say uint task count. So state variables inside of Solidity are actually written to the blockchain. And that's what they're called, state variables. They actually represent the state of this smart contract on the blockchain. And the state of this smart contract is going to change anytime this task count changes. And these are a lot like, class variables in an object-oriented context, where the scope of the variable belongs to the entire smart contract and not necessarily like a function or something like that. We'll see that more as we continue on through this tutorial. But initially we can set this value to 0 like this. All right, we just say equals 0. And we can also create a way to read this value from the smart contract with a keyword called public. All right, and what that does is actually provide some a function for us that allows us to read the value task count from the to-do list. And Solidity kind of just magically gives us a function whenever we use this public keyword. All right, that's all we'll do for our basic smart contract in order to set this project up and actually deploy this to the blockchain and make sure that everything's set up correctly. We'll come back and build this out throughout this tutorial, but for now we just want to do a simple check to make sure everything works properly. Now let's actually compile this smart contract before it goes to the blockchain and make sure that we wrote all our code correctly. We'll go to the terminal and type truffle, compile, and we can see that it actually created some new files here. I'll show you that in the project. If you go to the build directory and then contracts, we'll see migrations and to-do lists.json. So this is actually a JSON representation of the smart contract that's created by Truffle, and it contains some information that's useful to us. This is the smart contract API, which is the abstract binary interface. We'll actually use this later in the tutorial when we talk to our smart contract in JavaScript. We can see the bytecode that was created by the smart contract. This is actually the bytecode that gets run on the Ethereum virtual machine. And yeah, there's a lot more useful information inside of here, but I just wanted to show you that initially. Now, in order to actually put this smart contract on the blockchain, we want to create a few more files, and I'll kind of give you a tour of the rest of the project structure here as we do that. In order to connect to the blockchain, we'll actually need to update this truffle-config file, all right? And I'm actually going to just paste some code inside of here. Again, you can get this code from the repository for this project, the GitHub repo that I've got down in the description below. You can just check out that link. All right, I'm just going to save this. And I'll explain what's going on here. Basically, inside of this configuration file, we have the network's key inside of this object, right? So what that does is allows us to specify several different networks, but here we have a development network that's actually connected to Ganache. So this is localhost, and this is the port that Ganache is running on. So while we're here, let's go ahead and actually make sure that Ganache is running. So you can open Ganache, find wherever you installed it, make sure it's open. And we can see that the port is 7545, right? And we can see it's localhost 127.0.0.1, port 7545. So now that we have this filled out, this is actually talking to the local blockchain. Now let's create a migration file in order to get the smart contract onto the blockchain. So if you go to your migrations directory, you'll see a file inside of here. It's called initial migrations. So I'm actually going to copy the contents of this and actually create a new file in the same directory. And I'll call it to, we'll say deploy contracts.js. Okay. What's inside of this directory? Well, these are migrations. I'm just going to paste this code in here. So what is a migration? Well, if you've come from another development background where you've used a database, you might have had to change the state of that database by adding new tables or adding columns to the tables. And that's because you're changing the state of the database, the structure, right, the schema. And that's essentially what you're doing in this project right here with a migration. Whenever you're deploying a smart contract to the blockchain, you're actually changing the blockchain state. Remember, the blockchain basically is just a big database in one sense. And whenever you put the smart contract on the blockchain, you're updating the state, and thereby you need a migration in order to do that, okay? And you'll see these migration files over here are numbered, and that tells Truffle what order they need to be run in. So make sure yours starts at number 2. And inside of here, what we'll do is actually change this, change migrations to be to-do lists. So to-do list from artifact require, Truffle creates an artifact out of this to-do list.json that we saw a second ago. And that's going to be just an abstraction of the smart contract that it understands in order to put it on the blockchain. Now let's actually run the migration and deploy the smart contract to the blockchain. So first, again, make sure that Ganache is running. Make sure that you've configured this correctly. And we'll run the migration like this. We'll just say truffle, migrate. All right, it looks like it was successful. So what we've done is actually deployed the smart contract to the blockchain. And if you open Ganache, you'll see that something has changed. With this first account, you see that the balance of Ether, the Ethereum cryptocurrency balance, has actually gone down by a little bit. That's because deploying smart contracts to the blockchain actually costs Ether, it costs gas. And we can see that this account has done that. It's actually paid the gas fee in order to deploy the smart contract to the blockchain. And Truffle, by default, uses the first account inside this wallet in order to pay those fees. Now let's open the Truffle console in order to check the smart contract that we deployed to the blockchain. We'll do it like this. We'll say Truffle console. Now we'll retrieve the smart contract from the blockchain like this. We'll say to-do list equals await to-do list dot deployed. So to-do list is the name of the smart contract that we created in the migration. You can go back to the project and see this to-do list, right? We've actually retrieved the smart contract, a deployed copy of it from the blockchain, and assigned it to this variable to-do list. And you'll see this await keyword here. So let me explain that. We must interact with the blockchain in an asynchronous fashion. And if you ever developed other JavaScript applications, you would know that there's a lot of different strategies for handling asynchronous actions, right? You can use promises. There's lots of different ways to do it. But with Truffle version 5, we've actually been able to use the async await pattern inside the console, which is really nice. You can just do things in a simple one line like this. Basically, this is just saying, wait for this finished result, and whatever the result is, assign it to this variable. So we can actually look at that. We can say to-do list. All right, you can actually see the result is the smart contract here. And I'll just pull this up so you can see. Let's actually get the address of the contract. We'll say to-do list, address. All right. We can see this is the address of the smart contract that's deployed to the blockchain. This is just where it's located. And now we can actually see the count of tasks that we created in the smart contract. So we'll say to-do list dot count. Task count, I think is what we called it. All right, we can see that it's 0. And now Truffle actually stores that as a big number whenever we retrieve it. We could convert it to a number like this. We could just say task count, assign it to a variable and say await. All right, we can say task count to number. And you see that it's 0. All right, so that's a good check to say that everything is set up properly. If you've been able to complete all this so far, you've been able to create a smart contract, create a new Truffle project, connect it to a blockchain, and actually put the smart contract on the blockchain and talk to it. If you have any trouble, just rewind the video and try to see where you might have gone wrong. What we want to do now is actually pause and commit some of these changes. I'm going to create a new Git repository. I'll say git init. And inside of here, I'm actually going to create a git file. You don't necessarily have to follow along with all these steps, but I'm just going to do them so that you all can see. What I'm going to do inside of here is create this git ignore file that ignores the node modules directory so that we don't commit all the node modules to source. All right, I'm going to say git add. I'm not sure what all these errors are. Sorry. I'm going to git commit. I'll say project setup. All right, so that's it for the first part of this tutorial where we've actually set the project up. In the next section, we're actually going to list out the tasks in the to-do list. Now let's list out the tasks inside of this to-do list. I'll show you the steps that we'll follow. First, we'll list the tasks in the smart contract, and then we'll do that in the console. And next, we'll actually wire up the client-side application and list the tasks there. And finally, we'll write some tests that make sure that the smart contract is listing the tasks correctly. So first, we'll go to our smart contract that we've been working on, to-do list, and we'll actually write the code to list out the tasks in the to-do list here. So first, we'll need a way to actually model the task. We do that with something called a struct. Solidity allows us to define our own data types with structs, and we can create a new struct like this. We can just say struct task, follows with curly braces. I want to give this some more attributes in a second. Let me pause and explain some more features of Solidity, right? Solidity is a statically typed language. In fact, you can see the data types listed here, uint. This is an unsigned integer, which basically just means that it's an integer that can't be negative, right? So integers can be positive or negative with a minus sign, a sign in front of it, or a positive sign. And so Solidity allows us to define this struct task here. And we can give it some attributes like this. We can say uint ID. This will be the ID task. And this is going to be an unsigned integer, which basically just means an integer that can't be negative, right? If it was a negative integer, it would have a sign in front of it. That'd be a signed integer, but this is unsigned. And the next thing will be a string, and we'll say the content. This will just be, the text. And next will be a Boolean, and that will be completed. And that'll represent the checkbox state of the to-do list, whether the item has been checked off or not. All right, so that's how we'll actually model a task on the to-do list with this data structure. And now we need a place to put these tasks. So where do they go? Well, we effectively want to put these in storage on the blockchain. How do we do that? How do we access the storage? We need to create a new state variable, like we did here, task count. Remember, task count is getting written to storage. It's a state variable. It's representing the state of the smart contract, which is written to the blockchain, the actual data storage. And we'll actually want to create a state variable called tasks here. But we don't want it to be, an unsigned integer. We want a different data type. We want something called a mapping. And this is going to take a key value pair like this. It'll say uint task. Okay. Now, mapping in Solidity is a lot like an associative array or a hash in other programming languages, where you store a key value pair, right? And when we declare this mapping here, we declare the data type for the key, which is an unsigned integer, and the task, which is, this struct that we defined here. And essentially, this is going to be kind of like a database for us. It'll have a uint, an unsigned integer, that will be the ID, essentially, of the task that we'll store here. So we can look for task 1, 2, 3, and it'll return the tasks, okay? And we also want to make this public, just like we did with a task count. And that will give us a reader function for free, provided by Solidity, that will allow us to access the items out of this mapping. All right, now we have a way to create new tasks and actually put them in the database, or the blockchain in this case. We'll be able to use this task ID reference here and store the task like this. So now we need a way to actually put this task struct inside of this mapping. To do that, we'll create a function called createTask. Say function createTask. And inside of here, we'll provide a single argument, which will just be the content of the task itself. So we'll say string memory, say content, say public. All right. Now inside of this, we're going to write some code that puts this task inside of this mapping. So the first thing we'll do is determine the ID of the task we're going to create, right? So that's why we're using task count. And you see that each task struct has an ID, and we want to increment this task count value anytime we're creating a new task to put inside of this mapping. So we'll do that like this. We'll just say task count. And we'll just use the increment operator. You might find this to be similar to other programming languages, where you're basically just changing this value by 1. All right. So once we've done that, we'll have a new task count, which if this is 0, and the first time we call this, it'll change to 1. And that means the first task that we put inside of this mapping, whenever we call this createTask function, will be 1. And the next time it'll be 2, and the next time it'll be 3. So now let's actually put it inside the mapping. We do that like this. We'll say tasks. That will reference the mapping. And we'll say task count. We can actually reference it by the key, which will be the unsigned integer here. And we'll just say equals, and we'll create a new task. we'll do that like this. We just say, task, just copy this, and we say task count. We just provide the arguments for the structs, so the ID, the content, and completed. So the task count is the new ID. The content is the content being passed in, from the function. And it's a new task, so it's not completed yet. So we'll just say false. All right. Now we have a way to actually put tasks inside the to-do list, which we'll need as a prerequisite in order to list tasks. We'll need some tasks inside of the to-do list in order to show them. And the next thing we want to actually do is, go ahead and populate our to-do list so that when we, call it up on the client side, it's already got some to-do items inside of it for us, okay? And what we can do is basically just add some tasks to this list whenever this smart contract is deployed. So how do we do that? Well, we do that with something called the constructor function for the smart contract. So if you've ever used another programming language that has like an initialize function inside of a class or some sort of object, maybe init or new, something like that, you've seen a constructor before. So basically, this is just going to be a function that's called whenever the smart contract is run for the first time, which in this case is upon deployment. Right? So inside of this constructor function, we can actually add a default task to the to-do list. All right? So we do that like this. We'll just say create task, and we'll just pass in check out appuniversity.com. All right, I'll put a semicolon here. So now whenever we access this smart contract for the first time, it will have a default task inside of it. So whenever we list the tasks out, there will be something there for us to see. And that way we'll know that this worked properly whenever we look at this in the console and connect our client-side application and write tests and things like that. All right, now let's actually compile the smart contract to make sure it worked. We could just say truffle pile. I'm gonna have some syntax errors or something like that. We'll see. All right, it worked. So now let's actually open the console to see if it worked. We'll say truffle console. Well, actually, first, before we do that, let's make sure we have Ganache running. Don't. So let's pull it up. All right, so Ganache is running. And now we actually need to migrate our smart contracts. We'll say truffle migrate. I'm just going to pass in the reset flag just to be safe here in case you had Ganache already running. So what does the reset flag do? Well, that would deploy a new copy of the smart contract to the blockchain if an existing one was already there. So like if you go, we change our smart contract code here. So if you added new functions or something like that, you could migrate with the reset flag to deploy a new copy. So I'm going to do that just in case you had Ganache running already. All right. Now let's open the truffle console. So I'll do that like this, truffle console. And what I'll do is actually list out the to-do items. So first, I will just get a copy of the to-do list. We'll say to-do list equals await to-do list.deployed. All right. Let's make sure the address is there. Say to-do list.address. Oops, misspelled that. Okay. Now let's actually list out the items. Now let me explain something about this mapping. We want to call this tasks function that's provided by Solidity to list out the task in the to-do list. And remember, we declared this public, so Solidity gave us a tasks function for free to reference this mapping. But whenever we call this function, it won't just return all the tasks in the list. And that's because Solidity doesn't do that for us. This mapping is a dynamic size. There's no way, natively to know how big it is inside the smart contract. And so you can't iterate over it, and you can't just return the entire thing. You actually have to reference the items out one by one. And that's why we're using the task count counter cache here. So if we know that this task count is 1, that means there's only one task on the to-do list. and we would just have to call this function one time to get that task, and we would pass in the ID, which would be 1 in this case, and it would return the task. If it were 10, we would have to do this 10 times. We would call this function once with 1, and that would return task number 1. We'd call it the second time with 2, and that would return task number 2, etc., etc., until we get to 10, which does return task number 10. So that's how we would do that. If you're doing that on the client side, we would do a for loop or something like that, which will get to when we reach that section. So for now, inside the console, we can just reference, the only to do that inside here, we're going to task is this one. So we can say task equals wait to do this. Task, say 1. Alright, there we go. So there's the task. You see the content. Check out documentary.com. You can see that it's completed as false. You can see the ID is 1. It's a big number, but we don't have to do that. Inside here, we'll put task ID. To number. That's 1. Task content. Sorry, it's not a function. It's just an attribute. Alright, so now we've actually migrated this smart contract to the blockchain, and we've been able to list tasks inside the console. Now let's put the client's application next to those tasks there. So in order to do that, we can create some new files. First, we'll create a directory to store the client side files. We'll just say this source. So we see a new directory we came up here. And we'll put a new file inside here called index.html. Sorry, source index.html. And we'll create an app.js file to store the JavaScript code. Touch source app.js. So we go to the project and see an empty app.js file and an empty index.html file. And the file we actually want to create these smart contract JSON files are. We also want to tell it where our node modules are to pull out some dependencies for building out the front end. So we'll do that like this. We'll actually create a new file, say touch JSON. Inside this file, I'm actually going to paste in some code. And you can actually get this configuration from the project and GitHub down in the description below. I'll paste this inside of here. And don't worry too much about this. This is always proprietary browser set configuration. Basically, we're saying the server configuration is this. We're pulling the files in from the source directory and also the build contract directory. Basically, it's saying expose all of these directories to our web server root. And then also, we're going to mask vendor with node modules. So any node modules that exist inside our project, we can reference those with the vendor route. Alright, so there's our server configuration. And now we actually want to fill in the index.html file. Now, likewise, inside of here, I don't want to spend a bunch of time writing HTML and CSS, so I'm going to just paste in the code from the application. And again, you can just pull this source code from the GitHub link down below. I'm just going to paste this in like this. What we'll do is actually build out the JavaScript part, but I don't want to spend too much time writing the HTML. So I'm going to paste this in here. I'll explain what's going on. Basically, we're pulling in the full bootstrap here, we can see the Dab University to-do list. You actually click through this link. It'll take you to my website, which is pretty cool. But yeah, so let's go in the project and actually list out the to-dos in this client-side application. For the list of to-do items, we essentially want to fill in this order list. We've got two here. We have a list for the tasks and then the completed tasks. So if we have an uncompleted task, we'll go in this list, and whenever we complete them, we'll go here. For now, they're all incompleted, so we'll stay in this task list. Alright, so in order to do that, we need to do several things inside this app.js file. This is where we'll actually create our JavaScript app that talks to the blockchain. So the first thing we'll do is actually create an app like this. This object. And we'll create a load function. I'll actually call this async. There's a lot of async functions inside this tutorial. I've been using a lot of async to load patterns loading data from the blockchain. It seems to be pretty helpful. We'll fill this in. And then in order to load the app, let's actually do this console log. And in order to load the app, we're going to try to load, so just say so we see the app's actually loading. Alright, now I'm actually going to put these windows side by side, and you can see that this to-do list is actually responsive, which is cool. We'll be able to see the tasks right here. We'll be able to focus on the code while we're doing this. The first thing we're going to do inside this load function is actually say await app.load web3. We want to load the web3 library in order to connect to the blockchain. Now when we load Web3, I'm actually just going to use the configuration that's specified by MetaMask themselves, right? What we're doing is creating a way to talk to the blockchain. We want MetaMask, which is going to be the browser extension that we use to connect to our DApp, our blockchain application, to talk to the blockchain with Web3.js. And MetaMask actually suggests a way to do that. So I'm not going to reinvent the wheel here. I'm just going to do what MetaMask tells us to do. So I'm going to actually just paste in the configuration that they suggest. And don't worry if you don't understand what's going on here. Just know that this works, and it's inside of the GitHub repository. And you can find the code with the link in the description below. So let me pause because I don't feel like I've fully explained Web3.js very well. What's going on here, okay? So remember, this to-do list application is backed by the blockchain. And we want to actually connect to the blockchain to use it. So a few things have to happen. We have to connect our browser to the blockchain, and that's what we're using MetaMask for. And then our client-side application needs to actually connect to the blockchain. And that's what Web3.js is for. So inside of our project, we'll use the Web3.js library to talk to the Ethereum blockchain. It'll actually allow us to connect to it and read and write data from the blockchain inside of the app. And then MetaMask will allow us to communicate with that client-side application with Web3.js and allow us to interact with it via our browser. So what we did here was just loaded up Web3.js, loaded our blockchain connection essentially. And we can call this like connect to blockchain if we want.
God, I got up. I wasn't even listening to him.
I may be
What are you
documenting
waiting
more
for me to
times,
school
but
for
I'm a
that
mom
long?
first. With COVID going
Después
around,
saca
seeing
tus
black
heridas.
kids at a higher rate, I'm telling any parent with kids 5 years and older, I'm going to get the COVID vaccine as soon as it's
Good.
first 50%. Now we know that now, if we were really on our stuff, we could see this coming maybe back in July with predicted such a drastic move, changing a $1 trillion company's name, especially because they were into something that said they are not the first metaverse company out there. If you remember, back in 2013, there was this company, virtual world called Second Life. It had 1 million monthly active users and still has thousands of users now. Now, this is much larger than something like Decentraland, which had about 1,500 daily active users. This was at the beginning of the year, and now back in March, it hit about 10,000. Now, I've seen different numbers on this. We're just going to go with 10,000 daily active users. I think that might be a little bit high, but I will go with that number. Now, compare this to Facebook. Let's take a look. So, market cap of Mana is about $5.7 billion right now. It's not a fully diluted market cap, it's just what they're at now. Facebook market cap is $931 billion. You compare the users, and you get a market cap per user of over $500,000 for Mana and $483 for Facebook. Obviously, there's a huge disparity. It's about 1,173 times more expensive Mana compared to Meta. You have to remember though that it's not all about the cost per user. Now that is not great, right? I would much rather have it be about the same, but they are different. One's a crypto, one's in a very quickly growing industry, and one of the companies, Facebook, has about 1/3 of the world using it daily. So one's a little bit more bulletproof, one's more speculative. You always pay more for something that's going to grow quickly, and you have to realize that they are very different. Mana has a lot of NFTs and in-game currencies, which is the way of the future, while Facebook is, I don't want to say a dying platform, but a platform that a lot of younger generations don't really like. They don't like the oversight, they don't like the big brother feel, which is where I think people will eventually turn to some of these decentralized metaverses. Obviously, a lot of people will be coming into Facebook's metaverse, and Facebook has a lot of money to throw at it, but people will be interested, in my mind, into the decentralized metaverses. They're interested in gaming cryptos. They're going to be interested in these virtual worlds where they can actually come out of it with something instead of just feeling like they've lost hours and hours sitting in it. So, with that in mind, Decentraland has come down a lot still. So we have to look at whether now is the time to buy. So we have gotten some big news recently. Adidas entering the metaverse, Nike entering the metaverse. Both of these make big splashes and push up metaverse cryptos. We also can see some of the land sales for metaverses, like Decentraland selling for literally millions of dollars. Lots of land selling for millions of dollars in Decentraland, and that definitely pushes up the price. I personally think that a lot of the metaverse cryptos will die. I think a lot of companies, a lot of projects are trying to get into the metaverse because it is a business. But unless you have top projects, I don't think you're going to get into I think just like Decentraland, maybe a few others. But if you look at social media, not many social media sites actually have done well. I mean, there are a couple that rule the internet: Instagram, Facebook, TikTok, Twitter, YouTube, if you want to call that a social media site. But a lot of these smaller ones die off. And I've said this before, but it's not like gaming crypto where there's a handful of different companies, or a long list of different companies that can make a good game. Of course, there are going to be some that we just don't see coming, but I think the winners will be some of the largest metaverse crypto out there. And they'll take the majority of the share of the pie, because people don't want to go into a social platform and not have anyone to interact with, or not have their friends on it. They want to go, they want to hang out, they want to have a good time, so they want to be able to that other people are. They don't want to go into a place where no one is. So I think well, obviously we have the overall market to look at, right? If Bitcoin goes down, also, people will be looking at these cryptos, right? A lot of people feel uncomfortable with cryptos in general, buying and selling cryptos, so they start by looking at the top projects, and they'll buy Decentraland, they'll buy the Sandbox. We'll see news for those different cryptos, and people will buy them. Now, it has been being down a good amount. We've seen some support recently, but we have to remember, we moved up very quickly. We moved up very quickly to this $5 mark. We've seen some support right under $3. I am going to start buying if we see it fall under $3 again. Now, I realize that we might not get there, and I'm okay with that. We saw some support here today. We saw some support a few days ago at $2.94. If we get under $3, I will start DCAing. Now, I'm not going to go put all my money in Decentraland because honestly, it's still expensive, right? It's still an expensive crypto. I am willing to dollar cost average a little bit. This is not my every investment plan because this year, I was also this year than some other investment plans, but I really look at
serious about becoming a blockchain developer, you can go on my contracts on the Ethereum blockchain. It's a contract-oriented language, which basically means that the smart contracts are the main as opposed to a dynamically typed language, and it supports stuff like inheritance, libraries, and lots of other stuff. So enough of talking about Solidity, let's actually jump in and start writing some Solidity code. This is a website that allows you to write Solidity smart contracts in your browser, and it has a text editor here and allows you to compile them and deploy them and run them. And that's exactly what I'm going to use for this tutorial. You won't have to download anything on your computer, you won't have to install anything, you can just visit this website. Use Remix and we'll write the smart contracts that way. So in order to do that, I'm going to go over here to this browser folder. You can see the file browser over here.
What's up guys, in this video I'm going to go through Decentraland.com, how to buy mana, how to buy your first Decentraland property. If you're a complete new investor and you don't usually go on the wallets outside of exchanges, then all this might be kind of new to you, but I'll try my best to explain it without going too much into the detail because then I'll just bore everyone. So basically, most people what they do is they've got their coins on exchanges. The coin that you need to be able to buy and sell land or buy and sell assets in Decentraland is the mana coin. And just like any other coin, it can be purchased on the major exchanges. We've already been listed on all the big ones, so Binance, Huobi, Bittrex, We are even. I'm pretty sure we're on Bitfinex as well. No, it's not. Here we're on KuCoin. We're on the mainstream exchanges. Like if you want to buy mana, you have a lot of options. So what you'll need to do is, if you're interested in a particular set of land, for example, if you go to Decentraland Marketplace, there's all these these are all the lands set for sale. Say for example you want to buy this one for 6,100 mana. Then what you do is you would purchase that amount of mana in your on your exchange. So you purchase it with Bitcoin or going to Ethereum, or you have on exchange, you have that amount of mana, and then you transfer that much amount of mana to your onto your wallet, right? Now the wallet that we use, that most people use in Decentraland, is this one here, which is a Chrome browser. It's called MetaMask, right? Now MetaMask is a Chrome browser wallet that you're going to probably be using if you're going to be buying more